Welcome to the Tech Talks Daily Podcast, where you can learn and be inspired by real-world examples of how technology is transforming businesses and reshaping industries in a language everyone can understand. Here is your host, Neil C. Hughes.
Welcome back to the Tech Talks Daily Podcast. Now today, I want to explore the world of 3D printing. So I went on a search to find someone who can bring this topic to life, and I immediately came across a company called Desktop Metal. And their 3D printing systems are a pretty big deal. For example, they have raised $438 million in venture funding since its founding, with investors from everyone such as Google Ventures, BMW, the Ford Motor Company, and that list goes on and on. But what about the story behind the company? Well, Jonah Myerberg, co-founder and CTO and SVP of Global Engineering at Desktop Metal, is going to join us on the podcast today. And he's responsible for leading the technical direction of the company's 3D printing solutions and driving global engineering efforts. And he's got quite a backstory as well. I mean, prior to joining Desktop Metal back in 2015, where he has held senior positions with a variety of organisations that have all been focused on things like performance battery development, including Renovo Motors and Boston Impact, where he originally founded, I think it was A123 Systems. And there, he led the motorsports business unit, which focused on the development of high-performance batteries. And his products were actually adopted by the majority of Formula One teams, including McLaren, Force India, Mercedes-Benz, Red Bull, and not to mention high-profile teams such as the Porsche 919 team, which I believe won the 24 Hours of Le Mans in 2015 and 2016. So I think it's fair to say he knows his stuff. So buckle up and hold on tight as I beam your ears all the way to the US, where Jonah is waiting to share his story today. So, a massive warm welcome to the show. Can you tell the listeners a little about who you are and what you do?
Sure. Yeah. Hi, Neil. My name is Jonah Myerberg. I'm one of the co-founders of Desktop Metal. I'm a CTO and head of global engineering as well. But I'm a mechanical engineer. And right now at Desktop Metal, we are making the world's most advanced 3D printers.
It's incredibly cool what you're doing there, but I'd love to take you back even further back before Desktop Metal was a thing there. So what was your origin story? Where did your passion for technology and engineering come from? What lit that spark and put you on this path you're on right now?
It's a great question. So I grew up in West Virginia, which is a big country here in the East Coast of the United States, the Appalachian Mountains. And to me, technology always represented freedom as a kid. I couldn't wait to get into a car. I couldn't wait to drive. And the more I learned about it, the more I wanted to be involved in the design and advancement of, whether it was an engine or the interior of a vehicle. I just was fascinated by technology from the very beginning.
And it was that path that led you to Desktop, which, I've got to be honest, is an incredibly cool name. It sounds like something out of Robot Wars or something. But can you introduce the listeners to the kind of problems that you're solving with the technology at Desktop Metal?
Oh, yeah, absolutely. So we're doing some really incredible and exciting stuff over here. But Desktop Metal was founded originally to democratize metal 3D printing, basically bring it to the masses and give no one an excuse why they should not be using it. And since then, we've grown it into what we're calling Additive Manufacturing 2.0. And that's the idea that 3D printing is now ready for mass production, not just for making onesie twosies or prototypes, but to compete with traditional manufacturing methods. So what we're doing here now is we're developing new materials, starting with the metals like stainless steels and super alloys, titaniums, aluminums, copper, metals that are compatible with our printers that customers can then take into mass production. But it's with Additive 2.0, it expands beyond. We expand into different types of carbides, carbon fibers. We have about 225 qualified materials across all types of metals and composites, polymers and elastomers, ceramics, even wood and sand, and now into the medical and dental industry with biocompatible materials, applications in dental or in orthodontic that are really exciting and opening up doors across those borders as well.
And just to bring to life what we're talking about here, do you have any stories or use cases that you could share that would just help anybody listening anywhere in the world understand how Desktop Metal is reshaping this future of mass manufacturing? Because it is incredibly cool, and I'd love to help them almost visualize, even though it's an audio podcast, of the kind of thing that you're doing here.
Absolutely. So 3D printing and additive manufacturing, it sits at this intersection of the digital and the physical worlds, right? So it enables what we call digital factories of the future to exist. All of our designs are created in the digital world, right, on computers, and they're refined through simulation. But when you want to get them out of that digital world into the physical world, traditionally that meant investing in tools. So long, expensive cycles of getting your part cast or dyed into existence. But 3D printing represents the direct path from digital to physical, enable this direct manufacturing method that we call digital manufacturing. And so it's enabling what we're calling the digital factory of the future, but that really means lights out manufacturing. It means completely automated manufacturing, advanced manufacturing, where we don't require these tools that are typically, expensive and huge investments that are used for a certain period of time and then are obsoleted and sit on shelves and then go off and are the tools that we use in the digital factories for 3D printing are files that sit on servers and then are pulled out of servers as they're needed for manufacturing. And then if they need to be modified, they're digital files, so they can very easily be modified. So it completely changes this landscape of manufacturing. And it also changes the landscape of supply chain. So the files that we're talking about can be sent around the globe in seconds. If you want to print something or manufacture a part in Asia or in the US or in Europe, you just email the file. And that enables this distributed manufacturing to exist. It's almost like edge computing. You're bringing manufacturing closer to the point of use. And that really makes manufacturing much more efficient, much more effective, much more cost effective. It allows countries to reshore manufacturing. For example, in the US, a lot of our jewelry manufacturing is sent overseas. And it used to be that gold and silver and platinum were manufactured in New York City on Manhattan. And that hasn't happened in a really long time. But 3D printing is allowing us to bring that back onto the Manhattan Island, which is really phenomenal. The pandemic is another great example of where we created what are called AM hubs, or additive manufacturing hubs, which are networks of 3D printers around the country, around the globe, where the same file could be sent to and then mass produced locally. And we saw this happen with nasal swabs, where we had 3D printers located around the globe that were capable of printing nasal swabs. We just had to feed them the right design, which we did. And then they started cranking out these nasal swabs and feeding it to the people in need. So that was a really kind of an unfortunate but great example of the way that additive manufacturing can be scaled and distributed.
And you mentioned a great phrase a few moments ago about building the future of digital factories. And if we do have people listening outside of the manufacturing space that are just fascinated by the technology, could you just explain what digital factories are, a little bit more behind that concept too, just to get everyone on the same page?
Yes, absolutely. So digital factories are a way that what's happening in Industry 4.0, or this next generation of manufacturing, which is toolless and smart. So if you ever walked through a heavy duty manufacturing factory, it's pretty dirty and rudimentary, and there's big presses running, and there's a lot of machinery and noise. That is what we've gone through in Industry 3.0, which is this mass production ramp of capacity for multiple different industries. But what was missing from that was an intelligence aspect. Collecting data from these machines, sending data to the machines and back to central locations that tell you about what's being manufactured, allow you to continuously improve what's being manufactured, allow you to store data and quality control on site automatically. This is all what we're capturing in Industry 4.0 and what we're calling the digital factory. And 3D printing really enables this digital factory, this smart factory, to exist because it has this direct connection from the digital world where we design to the physical world where we're using and testing the components. And you want that to be as direct as possible in these digital factories so that there's no analog tools that are sitting on the shelf that are unintelligent tools. You want everything to be very and very well connected and therefore very flexible and able to be continuously monitored and continuously improved.
And I think for the first time, certainly in my lifetime this year, we saw so much focus on just how fragile the supply lines are around the world, and the supply shortages throughout the holiday season is something that has impacted just about everyone. So how can this kind of manufacturing impact supply chain and shortages in the future, do you think?
Yeah, it's a great point, and one that we're experiencing firsthand with the pandemic and the supply chain shortages that we've seen, where materials, or I should say parts, are sitting on shipping containers and shipping boats in the middle of for weeks on end. And the question is, how do we avoid that in the future? Well, first of all, how did we get into this? Over the last century, we've been centralizing our manufacturing in countries that have had the cost structures and the material resources to support the supply chain. These are low cost economies, usually in Asia, where the manufacturing is less expensive, and then factories are just built up there, and therefore concentrations of raw materials flow into there, and then parts flow out of there. And that's a very difficult supply chain when you get into mass distribution around the globe. And we're seeing it with these boats, that you have to travel these channels in order to get from the east to the west. And if anything goes wrong, you feel it, and you feel it for weeks, and you feel it everywhere. What digital manufacturing and additive manufacturing represent is this ability to distribute manufacturing away from this centralized location, which then the raw materials will redistribute as well. So you have essentially a raw material that is universal, that you build from. That raw material is distributed just like these smart factories are distributed. And then the files, the designs, everything that feeds the factories are sent closer to the end use. So for instance, here in the US, we have automotive manufacturing in Michigan, up in Detroit. And we have set up additive manufacturing hubs that are in close by. And it allows Michigan to reshore a lot of those manufacturing sites so that you're now printing parts for the automotive assembly lines that are located there in Detroit, instead of shipping them, from wherever in the world that they're being manufactured across the ocean, long lead times, having to order them months and months ahead of time. They can now be produced on demand in the state of Michigan.
And of course, there's also a huge focus on sustainability right now, especially in the manufacturing space. So what does your tech play in helping factories be more sustainable? Because it's so important right now, especially for manufacturers to be showing that they're taking this seriously, aren't they?
Oh, yes. Oh, yeah. And sustainability is a huge passion of mine personally. I think that from the very beginning, additive manufacturing has demonstrated as this ability to react faster, to manufacture on demand, to produce less waste, and to optimize essentially this shipping and the logistics and the supply chain that feeds both the factory and that the factory feeds to their location. So right there, you get this immediate benefit of reduced carbon footprint just due to logistics and supply chain, as well as this optimization of the amount of material that you're using. Because additive manufacturing allows you to design the parts for their function, essentially using only the amount of material that you need for that, and instead of removing 90% of the material that you don't need and leaving only the material that you do need. So it's a revolution in the way that parts are designed and made. So it allows the customer to optimize their design for their application. And this is a huge part of what the UN has been talking about in this circular economy, this circular manufacturing economy, and what we call the circular vehicle or the circular car, where you want to use only the material that you need. You want to lightweight your parts, which lightweights the vehicle, which reduces the volume of the car, reduces the size of the brakes you need. It reduces the size of the battery that's in it nowadays with the electric vehicle. It's this concept called reductive decontenting. So as you begin to reduce the size of the component, everything else reduces as well. And then we look at the life cycle of that vehicle. All of a sudden, you're using more metal parts instead of plastic parts. The metal parts are infinitely recyclable, while plastic parts really only have 1 or 2 lives before they have to be landfilled. So this entire life cycle assessment of additive manufacturing and the role that it plays in sustainability is huge. And then, and I can't leave this topic without mentioning this recovery of waste materials that we're demonstrating now also, where you take materials that are normally landfilled and thrown away and turn them into usable materials to print parts from. And we're demonstrating this with our Desktop Metals printers. And Forest takes wood fiber that is normally scrapped and thrown away and uses it to print wood parts, basically gluing the wood back together using the sap from the trees. And it's almost reconstructing a tree from its sawdust. And this is a way of demonstrating that, hey, the scrap material that we normally get rid of can be reused and turned into real usable functional parts. And that in itself adds to the sustainability of all manufacturing across all industries.
And we are at that time of the year where there's that almost tiny window where everyone's optimistic about what 2022 will bring. So with one eye on the future months, are there any examples you can share of how it can also help businesses expand into new fields like space tech and healthcare? Because again, it's an incredibly exciting space right now, isn't it?
It really is. It really is. And there are so many space companies and rocket companies. And if you really look into the rocket companies and the rocket engines that are being designed and built right now, they are leveraging 3D printing more than almost any other industry is. 3D printing and additive manufacturing, especially of these high performance metal components, are enabling these rocket engine designers to make new rocket engines that are smaller and more efficient, taking thousands and thousands of components and reducing them down to few or even single components that make up these engines. And that allows us to make lower cost engines, to make reusable rockets that we can shoot up and then recover, like we're seeing right now. That's reducing of launches and the cost of space travel. And it really is an enabling technology for space. And that's just here on the ground, getting up into space. But once you get up there, what do? We land on the moon and we want to colonize the moon or colonize Mars. We don't want to take all of our raw materials up with us, right? We're not going to take a pallet of lumber up there. We're going to use the raw materials that are already there. And the way we do that is by mixing those raw materials and 3D printing them while we're there, 3D printing them into structures that are a lot stronger and more efficient than anything we could have brought with us. So, this 3D printing is really building business cases that expand into space. And you mentioned healthcare also. That's a really good point. Healthcare is leveraging additive manufacturing like no other industry, because healthcare requires either external prosthetics or internal implants that directly match the body, and everyone's body is different. So you can't have a small, medium, and large. You can't have a size 1 through 10. You need a custom fit for the patient. And additive manufacturing allows you to go capture that data in a CT scan or an X-ray, copy that data, and print exactly what you need. Custom-made implants, custom-made prosthetics made on demand that fit and function like never before. And that it's really amazing what the medical industry and dental industry is doing with 3D printing right now.
Wow, incredibly cool and exciting in equal measure. And what's next for Desktop Metal? Is there anything you can share about what you're going to be focusing on this year and beyond?
Yeah, absolutely. So Desktop Metal is continuing to drive what we're calling the AM 2.0 adoption. That is, it's taking 3D printing into mass production, where we unlock new materials. We show and build paths to waste recovery. We're really competitive already, at parity with traditional manufacturing. And as we grow, the cost comparison will get better and better for additive manufacturing. I mean, we're still scratching the surface of getting into mass production with additive manufacturing. And as we do, the cost of materials will come down, the cost of machines will come down, new applications will be unlocked. The industry has grown at about 25% annually, and this is increasing every year. It's expected to reach like $146 billion valuation just in additive manufacturing by the end of this decade alone. So the flywheel is spinning, right? The flywheel is already running, and we've got adoption at the highest level. Companies like Adidas, Stanley Black & Decker, Ford, BMW, Eaton, and the US Navy. These companies are already on board and running with additive manufacturing, which means that it's happening. It's happening. And so if I want to leave you with the 4 trends of what Desktop Metal is really focused on right now, it's the design of the function over the process. As a mechanical engineer, we design parts as much for the function as we do for the process. And that means how you manufacture it. We will now be able to reduce a lot of the manufacturing constraints that engineers face when they design parts, because additive manufacturing unlocks a lot of those constraints and allows engineers just to design a part for function instead of the manufacturing process that you're constrained to. The supply chain that I mentioned earlier, that supply chain resilience will be strengthened with additive manufacturing and reshoring manufacturing to the point of use. The sustainability that you talked about, huge benefits in reducing carbon footprints across the industry of manufacturing, which is bigger than the industry of automotive. We have a lot more work to do to clean up the manufacturing industry than anyone else. And then job skills. We need to educate our engineering youth, the new engineers coming out of college. We need to educate them with the new skills that are needed for additive manufacturing. So that's what Desktop Metal is focusing on, are those areas right now going forward to help to drive adoption.
Wow, sounds like going to be incredibly busy. And we've almost come full circle now, because we began our conversation talking about what put you on this path and what inspired you and where your passion for this topic came from. But I'm now going to have a bit of fun with you and ask you, what was the soundtrack to your career? What is there a particular song or piece of music that inspired you or helped you get your head in the zone before going on stage, or just remind you of your career in tech? What would your song be and why? And if you've got one, we'll add it to our Spotify playlist.
That's a great question. So I think if I look back at what drove, the one song that keeps jumping up in my head is called The Wheel by the Grateful Dead. The wheel is turning and you can't slow it down. It just reminds you that, hey, the world is moving forward. Keep on, things keep happening, and you need to hang on for the ride, and you need to be part of it. And so The Wheel drove me and continues to drive me, and I think it's a great song.
It really is. I'd almost forgot about that track. Man, that was a great choice. I'll proudly add that to our Spotify playlist. And for anyone listening that would just like to find out more information about Desktop Metal, the work you're doing, or even contact your team, what's the best starting point?
Come to our website, www.desktopmetal.com. You can find me on LinkedIn, Jonah Myerberg at Desktop Metal, and every social media platform you can find Desktop Metal. We show off what we do all the time. It's amazing, the use cases that we publish, really exciting stuff, and hopefully it inspires you too.
Well, you've certainly inspired me today. I obviously, over the last few years, 3D printing has been somewhat of a buzzword, but learning more about real world situations and scenarios of how it designs and markets 3D printing systems over there at Desktop Metal, combined with digital factories, increased sustainability, and all washed down with your great story. And not only that, we've got a great tune as well to leave me with. So thank you so much for taking the time to sit down and share it all with me. Thank you.
It's my pleasure, Neil. It was great to talk to you.
Wow, a big thank you to Jonah for educating us all on digital factories and manufacturing impact on supply chain, and the role that tech is actually playing in helping factories become more sustainable and helping businesses expand into new fields like space tech and healthcare and so much more. But man, what a great start to 2022. So as always though, keep your thoughts and observations, insights and experiences coming over to me. If there's any big talking points you'd like to comment on, or if you've got a question you want to ask, or you want to come and join me on the show, email me, techblogwriter@outlook.com. My website is techblogwriter.co.uk. You'll find links to all my social channels and 2,000 podcast interviews. But that's it for today, so a big thank you for listening, and until next time, don't be a stranger.
Thank you for listening to the Tech Talks Daily Podcast with Neil C. Hughes. Remember, technology works best when it brings people together.